On.
Hello, today we're going to be talking about the real number system. We're going to start off by taking a look at a visual representation of the real number system. The first set of numbers that we're going to look at is the natural numbers, which is also sometimes referred to as the counting numbers. This is the set of numbers that when we were little, we started counting 1, 2, 3, ... They go on and on forever in intervals of 1. So all of those numbers are natural numbers. The next set of numbers is the whole numbers, and those are all the natural numbers and 0. Remember, 0 is a really special number. It's neither positive or negative. And by adding that 0 in, we add in the whole numbers. So those are numbers like 0, 1, 2, and 3. Notice how the natural numbers are also included in whole numbers. Next, we have the integers. And the integers are all the whole numbers and their opposites. So that includes our negatives. Things like ... -3, -2, -1, 0, 1, 2, and 3. Next, we add in our rational numbers, and rational numbers are numbers that can be written as a ratio, things like fractions and decimals. So an example of a rational number would be 1/2, or it could be negative 0.4. And it could also be things like negative 1/8. All of those are examples of rational numbers. Another example of a rational number could be 0.3 repeating. 0.3 repeating is also 1/3. It can be written as a ratio, so that classifies it as a rational number. The last last component of the real number system is irrational numbers. In 6th grade, we don't deal with irrational numbers that often, but they are numbers that do not terminate or repeat. Things like pi, which is something that we'll learn about in 7th grade, that deals with circles, or the square root of 2. That's an irrational number as well. Again, it's not something that we deal with in 6th grade very often, but it is a component of the real number system. And then the actual definition of the real number system is the set of all rational and irrational numbers. One thing that we should make sure that we realize, notice how rational numbers includes everything on the left side. We've got our natural numbers, which is inside of our whole numbers, which is inside of our integers and inside of our rational numbers. And then irrational numbers is on the opposite side. There is no way that a number can be a rational number and an irrational number at the same time. Now, I want to take a look at a different representation of the real number system. Same concept, a little bit different representation. One of the ways that I taught you guys in class is to remember the order of the real number system is the statement, never write in red. And when we remember that statement, we remember never write in red. And that's going to help us to remember the order of our rational numbers. We start off with the natural, then the whole, then the integer, and then rational. And then irrational is over here. So what I want to do with this visualization is throw out a few different rational numbers or irrational and then place it correctly in the Venn diagram. So the first number that I am thinking of is negative 12. The big thing that I notice about negative 12 is that it has a negative sign. The second I see that negative sign, I'm automatically thinking it's probably an integer. And negative 12 is an integer. The next number I'm thinking of is the number 3. Well, 3 is one of those numbers that whenever I was really little, I started counting. And because it's a number that I started counting whenever I was little, I realized that it was probably a natural number. What about the number -3/4? This one is one that I really want you guys to think about because it's a negative number. So some of you may be thinking, oh, it's a negative, it's got to be an integer. However, because -3/4 is also a fraction, cannot be an integer. It has to be a rational number because it's that fraction. So -3/4 needs to be put in the rational component of the Venn diagram. And what about the number 0? 0 is that very special number, neither positive nor negative, so it goes in the whole numbers. This was a very quick representation of the real number system, kind of gave us a little tutorial of it. Please let me know what you guys think. Thanks.